Welcome to Enactus VU. My name is Sarah Arrowsmith and I'm the team president of Enactus VU. At Enactus VU we have 4 projects. They are Kabaya, Setu, Girls in STEM and the Plastic Solution Project. Today I am joined by 3 members of the Plastic Solution Project. They are Daniel Jatt, the team leader, Bryce Cochran, the head engineer, and Sarah Plant, the head of the school program. I'll now pass over to Daniel to tell us more about the Plastic Solution Project.
Thanks, Sarah. One of the founding goals of the Plastic Solution Project is the successful repurposing of waste plastic that is collected locally, either taken out of the environment explicitly via cleanup events or implicitly through waste collection bins placed in schools and local community areas. This goal was born out of China's Operation Sword initiative, enacted in January 2018, which banned the export of Australian plastic waste to the region, putting extensive pressure on Australia's own recycling infrastructure, resulting in many local councils not being able to process the recycling and simply putting their plastic waste into landfill along with regular rubbish. In September 2019, more than 4,600 tonnes of recyclables were poured into Victorian landfill in a 1-week period. We started with organising a few small cleanup events while beginning plans to build a machine that was capable of producing raw material out of the waste that we were collecting. Members of the community started taking a bit of an interest. We were able to partner up with Maribyrnong City Council and organise a large cleanup event of Edgewater Lake and surrounds, an area within the council's domain. Rotary associations also became interested, and we were even fortunate enough to secure a donation from the Rotary Club of Keilor East after presenting our project at one of their meetings. So once we started becoming more familiar and involved with the recycling world, we began to learn that there was quite a lot of confusion surrounding at-home recycling. Many people are really quite unsure if certain things belong in the recycling bin or not, and are also unaware of what happens to it afterwards. With rules and practices differing across states, and sometimes even between councils, it is not difficult to understand the source of this confusion. That's when the second pillar of our project emerged, the goal of promoting awareness of recycling practices within the community through the education of young people about plastic, our relationship with it, how to recycle it correctly, and the consequences of what occurs when this does not happen. So now I'd like to have a chat with the leaders of our 2 main initiatives, Bryce, head of our engineering processes, and Sarah, leader of our school program initiative. Okay, let's start with you, Bryce. As current head engineer for PSP, how are we currently striving to achieve our primary goal of repurposing plastic waste?
Thanks, Daniel. Throughout the last 2-year time period, we have strived to collect as much recyclable plastic products as possible and have established connections for acquiring particular variants of these used plastic products. Connections to collecting this plastic waste includes the 3 separate cafes at our campus. And through them alone, we were able to collect plastic milk cartons, which are made of high-density polyethylene, or HDPE for short, which is the plastic type we are currently prioritizing. We are prioritizing this type as it has been the most readily available of use to us, and prior to the COVID-19 situation, we were collecting 50 bottles per day, which equates to approximately 10 kilograms a week.
Okay, so having all this plastic stored nice, organised and neatly is all great, but what can we actually do with it?
Well, Daniel, we are shredding it. Our engineering team's largest achievement so far is our multi-purpose plastic shredder. Using open source designs, which we have made minor variations to, we have constructed an efficient method to process the collected plastic products. The machine you can see here was finished in July 2019 and has allowed us to process up to 60 bottles of HDPE plastic in an hour. We have also experimented with the majority of types of plastic, as due to our choice in motor for the shredder, we are able to shred all plastic types and most plastic products. Our processing rate for shredding of the plastic can be improved further once we are back at the university and have access to all of our machinery, tools, and equipment. The process of shredding the plastic has already been improved since the shredder's completion and is only going to get better with time.
Do you think you could give us some insights into some of the uses of shredded plastic within the community? Because it doesn't seem like you'd be able to sell it very well, and it presents a even more dangerous form of pollution in the form of microplastic.
Oh yeah, definitely it does. Microplastics are a huge issue to the environment, which is why we're taking that shredded plastic and we've been safely working with it for months. We have been experimenting with the process of making small-scale products, but during this time, it was made abundantly clear to us that we needed to use more shredded plastic at a time to produce larger and better quality products. Hence, our decision to make a sheet press. As you can see, this sheet press is currently what our engineering team is prioritizing, and once constructed, will be able to provide us with a 1 by 1 meter sheet of plastic of varying thicknesses that will allow us to make a variety of products such as coffee tables, chairs, garden beds, timber replacement, or even simple storage containers. We have acquired our design for the sheet press from the same open source solution as the shredder, hence both pieces of machinery are designed to work hand in hand together. The sheet press is our next biggest hurdle, as after constructing it, our ability to produce quality products will only be limited by our imagination.
Great. Do you think you'd be able to elaborate on these products for us and maybe comment on the processes for developing these products?
Okay, sure. Well, while we've been under self-isolation conditions, we've been focusing on optimizing our product designs and developing a product plan for the sheet press construction. By doing this, we have used our engineering team's time and resources to become the most prepared for when we return and commence product creation. Although our main priority so far has been the garden beds. They have the highest potential to use large amounts of plastic and requires a minimum amount of post-processing, and hence they have the most efficient production rate, which results in the best revenue and customer happiness guarantee.
Thanks for the chat, Bryce. I'd now like to take it over to Sarah, team leader of our school program. So Sarah, would you like to tell us a little bit about this program?
Yeah, thanks, Dan. So the Victorian and Australian curriculum recognises sustainability as a cross-curriculum priority. It's a topic that's multidisciplinary, meaning it can be integrated throughout a range of subject areas. Our school program aims to educate future leaders about the importance of sustainability and the positive difference students can make when it comes to plastic and recycling both in and outside of their classroom.
I know the school program has undergone some development over the past few months, but you can tell us a little bit more about the initial structure of it?
Yeah, definitely. Our initial vision for the school program started out with having 3 face-to-face sessions, which involved our team arriving on campus and facilitating the delivery of these sessions. Early this year, we started developing content delivery plans for each session so that any member of our team could deliver the program. Keeping the curriculum in mind, our sessions were devised with a central topic, learning intention, success criteria, focus questions, and of course, our session content. Our initial target audience for the program was Year 5 and 6 students, with the ability to adapt to higher and lower year levels. Our goal by the end of June, early July 2020, was to have delivered our program to at least one school to test the effectiveness of delivery and to improve upon our session structure. In February, we started reaching out to schools and found that schools are reaching out to us, which really just reflects the demand and relevance of our program, which is just fantastic.
So what does our school program look like now, given the impact of COVID-19?
With the shutdown of schools due to COVID-19, our program has had to adapt in order to remain relevant in today's classroom and digital learning space. So, in addition to our face-to-face delivery, our school program is now tailored to a remote online learning approach with modular-based sessions and video content. In the past 3 months, our program has evolved not only to meet the needs of current education, given remote learning, but our program is now more scalable and holds the potential to reach rural schools, schools nationally, and even schools globally, if we're thinking big picture. Currently, we are in the process of developing our video content and activities to consolidate student learning. One of our talented members, Aisha, has developed an interactive online game using the program Scratch. The game involves students identifying different types of plastics, how to sort them, and the environments and animals impacted by plastic pollution.
So what would you say the benefits are of this evolved school program?
Well, Dan, we're better able to meet the needs of schools because we now have different delivery options. So once the threat of COVID-19 has passed, we can go back into schools and deliver a face-to-face program if this is what schools want. But for schools in rural areas, schools in different states, countries, or just for schools who prefer that online option, we have that. Ultimately, we can tailor prices for these different modes of delivery. Plus, online leads to greater availability of staff, scalability, and it's also more environmentally friendly because there's no travel. But no matter what delivery option schools choose, we're still aiming to engage students about the importance of sustainability and the positive impact students can make when it comes to plastic and recycling.
This project is currently funded by the generous donations of Rotary Keeleries and university grants. Currently, we have $3,545 in our bank account. So Daniel, where do you think we will be financially in 12 months' time?
Well, we aim to be making $1,000 in gross sales per month come next Enactus conference. We will achieve this by continuing to purchase and create high-quality machinery. The sheet press, which may cost up to $3,800 to produce, though we aim to reduce this amount by utilising staff and students on campus. And in order to maintain a high level of production and sales, we foresee a need to invest in an upgraded double-axle shredder, which will increase our plastic shredding rate from approximately 4 kilograms per hour to upwards of 35 kilograms per hour. Unfortunately, due to COVID-19, we have had minimal access to the university campus, resulting in us being unable to produce revenue with both our school project and production operations coming to a halt. However, we are currently discussing access to our infrastructure with university officials, and once we can resume operations, we are confident in our capacity to produce revenue very quickly, with our almost negligible cost for plastic collection and a greater reach to schools with our online delivery.
For more information about the Plastic Solution Project or any of our other projects, please don't hesitate to get in contact with us via email, Facebook, or our website.